Hello. Come up here. Hello, my name is Markus Bandhofer. I have a company called Solartechnik Bandhofer, here in Sachsenkam in southern Germany in Bavaria, and I would like to show you how to build a solar panel system. We will now start to install a small system using this solar training kit. As I said, it is a training kit with a very small solar panel which has 10 watts of power. This is a battery, like the kind that's built into a motorbike or something of the size. And this is a charge controller. It is a solar panel system. You can run different loads from the battery, such as a lamp. You can use these 12-volt sockets, which everyone knows as cigarette lighters in cars, to operate various loads. The central element is this charge controller. The charge controller will practically distribute the current generated by the solar cell. It will supply the battery, and it will supply the consumers. Basically, this charge controller has 3 connections: solar cell plus and minus, battery plus and minus, and the loads plus and minus. The loads are the end users. This is a 12-volt solar panel that generates direct current. This direct current is fed into the battery. That is, 12 volt is the nominal voltage which will charge the cells at a level of about 17 volts. Let's begin with the installation. I'll start by connecting the solar cell to the charge controller. We'll do it with standard clamps. These clamps have a lever here. With this lever we open the clamp, then the cable is plugged in here and the clamp is closed again. I need 2 clamps for plus and minus. Here is the charge controller, solar cell plus and minus. This is already stripped. Otherwise I have to do it first. Strip 1 centimeter from the cable. Now I put this clamp on and close it. Likewise on the other pole. Then I open the terminal box on the solar module. And I connect the solar module to the charge controller. There are now cables here with a square millimeter cross-section. If you build a larger system, you will use cables with 4 or 6 or even larger cross-sections. But because this is only a demonstration of the training kit, here I am working with smaller cross-sections. Here I connect the positive pole of the solar cell to the charging regulator. And here the positive pole of the solar cell. Here a rounding around the screw. Of course you could also press on a ring. I do the same with the negative pole. Red is usually plus, blue or black minus. I'm just going to strip this cable a centimeter. This is an automatic wire stripper. Then I'll twist and clamp it here. The other side I'll do the same way. I'll feed it in. And then put it under the screw and clamp it on. So now we have done the first part, connected the solar cell to the charge controller. Now we need to connect the battery to the charge controller. I connect the positive pole of the battery to the charge controller via fuse. This is simply a safety device. If too much current were to flow from the charge controller, the battery could be destroyed, damaged. And if I set a fuse, the first thing that will happen is the fuse will blow and the battery will be spared. This is a 10 amp fuse, which I put in a prepared holder here. You could compare this to a fuse that is used in a car. Now it is inserted here. A 10 amp fuse close the lid. Now I connect the battery. I use these clamps again for this. I start with the positive pole of the battery here on the charge controller. The battery has plugs here and is connected via such plugs. That means I insert the cable here and press the connector with a standard crimping tool. Then I check whether the plug holds. I check the positive pole again, and then connect the cable to the positive pole of the battery. Now that's connected. Now we do the negative pole of the battery. This can be done without a fuse. I use a blue cable. In this case I have doubled the cable because it has to be a bit stronger for the plugs, otherwise the plugs won't hold. I also have a stronger cable diameter when I double it. I am stripping the insulation and screwing it in. The other side is already stripped. The second one too. I will now twist the two together, then it is practically like a stronger cable. Here I also put in a plug and press the plug again with these crimping pliers. This crimping tool has indications for different cable diameters. I'm going to set it here to about 1.5, which is roughly what this cable diameter will be, and I'll use that to crimp it. Okay, now I'll connect it to the charge controller. Let's make them both exactly the same length. Also twist this. Here to the negative pole on the battery on the charge regulator. And now I'll clamp this to the negative pole of the battery accordingly. So that's the second step. The first step was to connect the solar module. The second step is the connection to the battery. The third step will now be to connect the end users. There is still one input free on the charge controller, loads plus and minus. I can use that here. For the loads, we will now use such commercially available 12-volt sockets, which can then be used to connect the users. As already mentioned, The socket is well known from the car sector as a cigarette lighter. Here, the connections on the inside are also made with plugs. In such a socket, the outer contact is practically the negative pole at the edge. The inner one in the middle is the positive pole. I will now again connect the negative pole with blue and the positive pole with red. Strip 1 centimeter of insulation. I connect it again with a clamp like this and plug it into the negative pole of the charge controller. I now connect this cable to the negative pole of this 12-volt socket. The connection is at the very back here, so I need pliers to get there. But I've managed it. The positive pole is still missing. I make a red cable for the positive pole. Again, double twist it and put a plug on it. Press the plug, it holds. I do the opposite side. Clamp it to the positive pole of the charge controller. And now connect the 12-volt socket to it. Good. We have now completed the installation so far. I have the center here, the charge controller, which has 3 lights. Overcharge, it says when overcharging. Charging, which lights up when charging. And discharge, which lights up when discharging. I now turn the module around to face the sun, which is the purpose of our project. And I see that this yellow light is flashing. This means that the module is charging the battery via the charge controller. The module generates direct current, which is fed into the battery. In contrast to alternating current, direct current is a positive current that never breaks down. Alternating current always has a zero crossing due to the sine curve. This means that with alternating current there are always moments when no current flows, and in this moment I can easily disconnect the circuit. This is not the case with direct current, where current always flows. That means I can't separate the circuit so easily. If I separate it now, I get an electric arc. This makes direct current comparatively dangerous, much more dangerous than alternating current. The fire hazard is greater with every connection. Every time I disconnect the circuit, I have an electric arc, and the current itself is also quite dangerous for people. The thing is, this system, this module charges with 12 volts, which is of course harmless. Basically, a voltage of 50 volts or more is considered dangerous for people. This means that when I build larger PV systems with several modules connected in series, I often have voltages of 500 to 1000 volts, which is life-threatening. You have to be careful. You must never touch both poles. In the high voltage range, this should be done by experts, electricians. Here I am in the range of 12 volt. 17 volt charging voltage, which is not dangerous. You still have to be careful, though, because if I were to connect both battery poles here, I would create a short circuit. Then I would create a lightning strike. And ultimately, there is also a certain fire hazard. I always say that the system, here is solar panel system, is a similar system to that in a vehicle. In every car I also have a battery. Only instead here the module generates the electricity, because in the car the alternator generates the electricity. But the system of the loads is similar. I have here a transition point for the load. I have this 12-volt socket, and I can connect different loads here. For example, a lamp, a soldering iron, and this inverter. This is an inverter here. It turns the direct current into alternating current. It has a plug for the 12 volts, which I plug in. And it is already switched on. Here it has a green light as a symbol that it is working, and now I can simply, it has a socket here, I can plug in this lamp. And you see, it lights up. As I said, these 12 volts are harmless to humans, yes. I can touch them, it doesn't hurt me, but the fire hazard should not be disregarded. If I connect this now, these two poles, I will create an arc, I will create a short circuit. I'll do it very briefly for demonstration purposes. You can see it's going black. It's practically starting to burn. This is a solar function kit that has been developed as a solar training kit. First and foremost, we can use it to build a small solar panel system, a real panel system, a functioning system.